Next up is Steve Kaffka, and he's the director of the California Biomass Collaborative, and we'll be sharing the biomass perspective.
Let's see if we can figure it out.
Right here.
Okay. That's just advertising for the next couple of days. Please come to the Biomass Collaborative. Jerry did give us a hard task, strategic needs for biomass, and I think it's particularly for all of these diverse sources of energy. I think it's particularly difficult for biomass because it is so variable and so diverse. I just wanted to point out we have a nice website. You can all join the Biomass Collaborative by going to that. I think these slides are all going to be on the web, so there'll be more detail if you want to come back to see them. Well, I have to have some background. This is the last governor signing AB 32. Many of you may recognize some of the people that are in the picture. This law profoundly alters the direction of economic development, in my view, in California. We're supposed to reduce our per capita greenhouse gas emissions by almost an order of magnitude by 2050. Nobody knows how to do this or if it'll be done. Not that the law was easy to write or pass, but in a sense it was the easy part. The law requires lots of guidance from public entities. It requires lots of regulation. But this older analysis by Wildavsky, I think, is still relevant. We're at the beginning of a profound social and technological transformation, and we can do regulation better the more that we understand the consequences of the regulation and the more that we understand the changes we have to make. But we're really at the early stage of that. We're down towards the left corner rather than the right. Nonetheless, we still need regulation. So this is really the larger problem that we all face as we move forward in the future with not only biomass, but with effectively social reinvention around energy use, which is our most important resource. California biomass resources, you can see this on the website, are very diverse. This is a coarse technical assessment of potential sources from agriculture, forestry, urban sources, and others. You can see that it's distributed around the state in diverse ways. Not only are the resources themselves diverse, but the kinds of technologies that can be brought to bear on their transformation are also diverse. You have thermochemical pathways, biochemical pathways, hybrid systems. You can make energy, you can make fuel, you can make industrial chemical products, precursors, all kinds of things can come from biomass, and they can come from biomass from the same projects at the same time. So what's the how does that all work out as in an optimization algorithm? So we know that biomass is variable in quantity and amount. It's unevenly distributed in space and time. It can be converted into many different products and using transformation pathways that in many cases are not commercially available or even not even invented. And it can have very large consequences for the landscape. So how can we know what will be the most efficient and sustainable ways to use these biomass for power and so on? Well, if Jerry had given me more time, I would have been able to give you the answers. So you're going to have to see me after the talk. But one of the messages that I want to emphasize in various ways in the rest of the time that I have is that all biomass is local. It's because it is distributed and it is diverse and it is variable, that optimization of biomass resources is going to be always a local phenomenon. And I use this picture to try to emphasize this. I'm an agricultural scientist, and so this is something we made up. This is the California landscape looking north, the Central Valley from the Delta, and if you go left to right and west to east, soils and soil formation processes and the kinds of resources that are available vary across the landscape, and they vary very profoundly. And the agriculture that's developed from that and upon those variable soil resources, using agriculture as an example, is itself highly variable. So there is no such thing as one place or one source of biomass. So what are strategic research needs? I have one slide with 4 on here. I could give you examples of stuff that we're trying to do in the collaborative from all of them. It's very important that we have good technical inventories. We need supply curves, price curves for important sources of biomass tied to different technologies. We need analytical and decision-making tools that can help industries, businesses, and public entities make better decisions. I think we need research technically on smaller scale and distributed biomass conversion technologies in particular, where you can do the conversion where the biomass is. But what I really want to emphasize today is the need for improved LCAs and particularly net benefit analysis. This is a study from the biomass roadmap that Brian Jenkins and others, including myself, contributed to. And it's a very complicated slide, and there's more information on it that I want you to pay attention to. But on the left, you'll see, in fact, that one of the early projections was that a lot of crops would be used for biofuel production in California. Now, this was done in 2006. It was used on fairly broad averages, and we don't think anymore that this is particularly a correct projection. So we've tried to develop, for instance, models that will help us much more realistically dissect the capacities of individual locations in California to, this is economic modeling, Jerry, as you mentioned, to identify really what the real resource is and what might be optimum locally. And what we have going on publicly in the United States and also at the state level is the use of top-down modeling, very large-scale national integrated or international integrated models. These they do not do a good job on the state or the state's resources, in my view. So we think that these local models will be much more accurately reflect the potential for biomass production and also the resources that are used in the process than these large-scale aggregate models. So here's an example of some output clustering. The NCA means the northern part of the Central Valley. SSJ is the southern part of the San Joaquin Valley. And what you have is water use in clustered regions that the model calculates in the numbers of crops per cluster. On the left is mostly a rice-producing region, which uses quite a bit of water per acre. And on the right, you see an area that has 14 different crops in cropping systems and uses much less 2 acre-feet. And so this kind of gives you just simply an impression of the fact that our farming systems are so variable and our regions are so variable. Each of these is going to have a different potential to produce, for instance, residues from agriculture or feedstock crops. So if you shock a model and you say, well, we want to have a biorefinery that's based on oil seeds, we have to pay $20 an acre more than the other crops pay, what happens? You find that not just one thing changes, a whole set of adjustments change. And that has an effect on resource use. In some cases you have savings, in other cases you have losses, you have different locations where these things occur. So this gives you an idea of how bottoms-up and more detailed and localized assessment works. Getting back to what I started with as a theme, change is very difficult socially. We have constraints. We can't just simply wipe the slate clean and start over. And when we add elements like sustainability, we know that there are often trade-offs, things that have to be given up for things that have to be gained. So really, the bottom line is what I think we need for biomass research is the capacity to do integrated assessments that are grounded on sound and practical understandings. A lot of times people start off at somewhere in the middle level of this cascade of modeling efforts and work their way down to the crop or field or woodlot model level. I think we have to make sure that those models are really well based in reality and that we start this process at least in part from the bottom up and do this well. I think we need these planning tools. We have a lot of things that are uncertain about biomass production and in the future in which the optimum will be, but I think if we have a good process like this established to support the state's objectives and businesses' objectives, we can be successful at it. So there's the advertisement again.